Hello, grade 5 students. How are you? Hope you're all fine and you try to work on the worksheet at home. In this video, I will read the questions, explain them, and if you have any mistakes, you can correct them. And for sure, if you still have any questions about the worksheet or the lesson, or you need any clarification, I will be always here to help. Question 1. To light up a bulb, you need to make a circuit. All the parts of a circuit must be connected in the right order for the bulb to light up. This is called making a complete circuit. Hassan, Lana, Ahmad, and Marwa each try to make a bulb light up using a battery and wires. Who made the bulb light up? Place a check mark in the right box. Let's see. We have here 4 different circuits made by kids. Let's look at Hassan's circuit. Hassan connected all the parts of the simple circuit in the right order. Okay, so both sides of the lamp are connected to both sides of the battery, but he missed to put the lamp in its place. So there is a gap in here and electrons cannot flow anymore in this circuit. So this is an open circuit and the bulb will not light up. So we cannot check this one. Let's look at Lana's circuit. Lana connected all the parts of the circuit in the right order. So the wires are connected to both sides of the lamp, and also they are connected to both terminals of the battery. So yes, the lamp will light up. Ahmad has the wires, the light bulb, the battery, but he connected the lamp to one terminal of the battery. Okay, so the lamp will not light up. This is wrong. Okay, he connected the wires to in a wrong way, so we cannot check this one. Marwa has the light bulb battery with the wires, but look at here, this wire isn't connected to the second side of the light bulb, so the lamp will not light up. Second question. When you turn on the light in your room, you're using an electrical switch. The switch closes a gap which completes a circuit so that electricity can flow. A switch can be placed anywhere on a circuit. Look at the circuit diagrams below. Indicate if the bulb is on or off on each one. Check the correct answer. Let's see. Let me first remove these. Okay. So, in the first and third circuit, the circuits are made of the same parts. That is a battery, wires, conductive wires, and light bulbs. And we have also the switch placed on different places, but these switches are opened. So the circuits have a gap and the electrons cannot flow anymore in these circuits. These circuits are open, so electrons will leave the negative terminal of the battery, but there is here a gap, so they cannot continue their pathway, and the light bulb is off. It cannot light up. Also, in this side, the electrons will leave the negative side of the battery. They will move through the light bulb, then they will arrive in here where the switch is opened and they cannot go back to the positive side of the battery. So this is an open circuit and the light bulb is off. Second circuit. This is a closed circuit. The switch is on and the electrons can flow through this circuit. This is a complete circuit again. So the light bulb is on. It will light up. Let's take a look on the fourth one. This looks like a closed circuit, okay, but there is no source of electricity in here. The battery is missing. So for sure, even if the switch is on and it's closed, but the light bulb will not light up. Question number 3. A simple circuit diagram often looks like a rectangle. It shows the loads, batteries, wires, switches that are linked together and how the circuit is organized. So circuit diagrams use symbols to show the parts of a circuit. As you can see in this one, this circuit is made of a battery, open switch, two light bulbs connected all to each other using by wires. So what we have to do in part A is to draw a circuit diagram for each of the circuits shown. I will start with the first one. The first circuit is made of a battery, two light bulbs with an open switch, and all of these parts are connected together by wires. So I'll start drawing the symbols. I'll start drawing the diagram of this circuit by symbols. This is the battery. I'll add the two light bulbs. And I still need to add the open switch. So this is the diagram of this circuit. It shows the battery, the two light bulbs, the open switch, and all of these elements are connected to each other by wires. Let's move to the second one. The second circuit shows two batteries, so we must draw and we will connect them to each other. As you can see, the light bulbs in here are in parallel. So they are not on the same line. They are found in different lines. The first lamp has an open switch next to it. And this is the open switch. Let me finish drawing the light bulbs. Okay, so this is the diagram of the second circuit. In part B of this question, we have to determine what happens in the second circuit if the switch is off. So the switch is open, is not on, it's off. So we should tell and explain what will happen to the light bulb, if they will light up or no, and for sure we have to tell why. So let's see. The electrons will leave the negative sides of the batteries. They will move and they have two pathways to go through. If when they go from this pathway, the switch is open, so they cannot pass and go back anymore. So electrons will choose or will follow this pathway only. So it's only the second light bulb that will light up. Okay, so what we have to say that is, if the switch is opened, electrons will not pass through the first pathway since it's cut. So the first light bulb will not light up. It's only the second light bulb, I mean this one, that is on. Okay, so I'll repeat. These two light bulbs are in parallel. So electrons in the circuit have two pathways to go through. But since the switch is opened, this means that the electrons will not follow the first pathway. They can move only through the second one. Okay, this way electrons will leave the negative terminal of the batteries. They will go through this light bulb and back to the positive sides of the batteries. Okay, they will not go through this pathway since there is a gap and electrons cannot flow. Fourth question. We have a circuit diagram made of a battery, 3 light bulbs, and open switch. Part A, indicate if it's a series or a parallel circuit. So as you know, a circuit that has only one path for the current flow is a series circuit. So the current flows in a path from the battery to the first bulb, then to the second and third bulb, And when the switch is on, the electrons will go back to the positive side of the battery. So this is a series circuit. Determine if the bulbs work in the circuit's current condition. What is the circuit's current condition? The switch is open. There is a gap in the circuit, so the electrons aren't able to move through this circuit. There is a gap, and electrons or electricity isn't flowing through the circuit. So the bulbs will not work. They are all off. Okay, the bulbs are off since the switch is off, or since the switch is open and electricity isn't flowing through the circuit. It's an opened or incomplete circuit. Clear? What we have to do in question number 5 is to draw a diagram for a circuit with one battery and 3 light bulbs in parallel. That means that the electrons have 3 pathways to go through in the circuit. I will start drawing the battery and the 3 light bulbs, then I will connect them together. This is the battery. And I will connect them to each other by wires. Okay, so as you can see, this circuit is made of a battery and of 3 light bulbs. The light bulbs are connected in parallel. This is a parallel circuit. The electrons have 3 pathways or roads to go through. In exercise number 6, we have to choose the correct answer. So they're saying, Miss Fata set up the demonstration lab for her class. When both wires touched the penny, the light bulb lit up. So the light bulb is on. What does this tell the students about the penny? Is the penny a good insulator? Is it a good conductor? Or the penny would be attracted to a magnet? What do you think? So, some materials, as we said, called conductors let electric charges and move through them easily. So we call them conductors. Insulators do not. In the circuit, since the light bulb light up, that means that the penny lets the electric charges go through. So this is a complete circuit with the penny. So we can easily tell that the penny is a good conductor. So this is what we have to choose. The penny is a good conductor. Question number 7. Ali put together an electrical circuit. As you can see, in Ali's circuit we have a battery, a light bulb, piece of wood, and all of these elements are connected to each other by wires. So, what is the way the light bulb? What's the way the light bulb will be affected in the circuit? Will the light bulb light up because wood is an insulator? It would not burn because wood is a good conductor, or it would light up because wood is a good conductor. So as you know that metals are good conductors, but wood isn't a conductor. It does not let the electric charges go through. Wood is an insulator. So this is the sentence saying that wood is an insulator, and so the light bulb will not light up. Okay, till here we finished our worksheet, and as I said in the beginning, if you still have any questions or you need anything, you can just contact me. Okay, bye bye.